Hey, PreCalc. It's Monday, and we're looking at Tuesday's test. And we had a couple more to do on our review from today's tally-ho. So, if you look on your sheet, you'll see that the next one is find difference quotient. So I think it was number 9. So go to number 9 or just work on another sheet of paper. Doesn't matter. So let me go a little closer here, and we'll find the difference quotient. So you're trying to get a tally. I'll give you the difference quotient. F of x plus h minus f of x divided by h divided by h. This is the difference quotient. Alright, so with the difference quotient, tomorrow you have to know it by heart, so this is it. For this tally, I will give it to you, but now to earn the tally, you have to use it. So turn off the video and do this if you haven't already. Alright, here we are back to see if you tally-hoed or not. So let's see. This tells me the name of a function, and this is what it does. And it takes whatever I put into it and multiplies it by 2 and adds 4. So this is asking me to put x plus h into this function. So I'm going to take the x plus h and multiply it by 2 and add 4 to it. Do you see how the x plus h took the place of the x? That was this part. Now I'm up to that part, minus, and the actual function follows as stated. Notice the negative sign in front. And all that's divided by h. That doesn't change. So now we just simplify. Alright. Distributing the 2 and the minus sign. And the fun begins, because if you've done the difference quotient right, you have some things that should cross out. And this ends up being 2h divided by h, so just a plain old 2. So if asked what's the difference quotient for f of x equals 2x plus 4, the answer is 2. That will actually hold meaning for you one day in your advanced math. So, for now, you're just a math monkey. Alright, let's continue to monkey around by doing the difference quotient for this one. The difference quotient, f of x plus h minus f of x divided by h divided by h. This is a different quotient. So, it hasn't changed. The song hasn't changed. So, this is the same. Again, I'm not giving you this tomorrow. Did you hear that? You have to know it by heart. It's called the difference quotient. So in this function, we have a new function. This is whatever I put in this function gets squared minus 3 times whatever I put in minus 2. So this tells me to put in an x plus h. So when I put that in, I get x plus h quantity squared minus 3 times x plus h minus 2. So that is completed, that step. Minus, and then f of x as described in the problem. And all that is divided by h. A little more simplification, but at this stage in your math life, you should be able to square a binomial with quite a bit of speed. Please, please don't tell me it's x squared plus h squared. If you did, just hang your head in shame. Alright, then minus 3 times each of those. And a minus 2, and then a minus everything behind that. All divided by h. Alright, so, oops, hang my head in shame. Alright, so I did that x squared, I'm sorry, hang my head in shame, in squares. All right, the difference quotient, you square this, you square this. When you square a binomial, you square this, you square that, and you multiply these together and double them. That's the quick way, and that's even the right way. All right, so now the fun begins. This crosses out this. This crosses out this crosses out this, and we have left, I'm going to gather what's left, 2xh plus h squared minus 3h all over h. And that can simplify further. If each of these has an h, I can simplify. So it's as if I'm pulling out of h out of the top, and I get 2x plus h minus 3, and I factor out an h, then this h crosses this h. And this is what's left. And it is the difference quotient. All right. For last one, number 10. So if you got this difference quotient, if you got a 2, you can tally ho. And if you got this difference quotient, 2x plus h minus 3, tally ho. All right. All right, so I don't have a great deal of confidence in your ability to find the difference quotient after watching your board work, so prove me wrong, please. Graph. All right, this one, notice it's not a fraction where there's a numerator and denominator, so there's no vahaha. It is just the plain old polynomial. So the polynomial that when we graph those, and this was not on last night's video because I was going close to 30 minutes and I just thought I'd review it today in class, which I did. For a couple of them, which one was it? Numero 8, ocho, number 8 we already did. So this is just like it, number 10. So again, if you haven't tried this, go ahead and turn off the video for a tally, and let's see how you did. All right, to begin graphing a polynomial, all we've done this year is look at the lead term and see that it's quartic. So when it's raised to the fourth, that means it's going to act like an even function, which is raised to the second, which is an up, up, or down, down. You can look at this term, if it's negative, or there's a negative sign in front, then it's down, down. This, however, is an up, up. So up, up, and away. The question is, what's going on in between? And that is where we need to factor. This is 3 terms, which is a little simpler to factor. So I look at 3x to the fourth minus 15x cubed plus 18x squared and say, what do they all have in common that I can remove? Well, I see they all have a 3 and they all have an x squared. So I'm going to pull those out, and this leaves me just x squared. This leaves me 5x. And this leaves 6. All right, so hopefully that's factorable, and I believe it is. So here are here's the first factor, the second factor, x, 2 numbers that multiply to give you 6 and add to give you minus 5. All right, so here's all our branches. And this branch, set that equal to 0, we get x equals 0. Set this branch equal to 0, we get x equals 3. And this one, x equals 2. So these are our zeros, and that puts a 0 here, a 3, and a 2. All right. Now, are any of these factors squared? This one is not. So it's called multiplicity 1. Multiplicity 1, we cross in those cases, but this is squared. So it's like we've got x equals 0 twice. So we've had twins. So we're going to act like this is a squared factor, which it is. With multiplicity 2 means we don't cross it, we touch it, which makes this one doable. So you want to finish the graph touching this 0, crossing and crossing, starting up, ending up. How cool is that? So that's how you graph a polynomial. So before I leave you tonight, I'm not going to do any more, but I'm going to discuss how you tell which strategy to use. This is a polynomial. It has no numerator and denominator, and it will be viewed as a down up. You would actually factor it, find the zeros, the multiplicity, and sketch it accordingly. This one, however, that's a 4 there, if you can see, and that 4 tells me that this will act like a squared, which is an up-up, except the sign in front causes it to be a down-down. So this one I would expect to start from down and end down in between. We find the zeros and the multiplicity. This one is the kind where you have a numerator and a denominator, and that will either be a va-ha-ha or a va-sa-sa, which is this one. Well, since the degree of the numerator is higher than the degree of the denominator, it is where we use the slant asymptote. So we have va-sa-sa. The verticals are always, no matter what case, they're always what causes the denominator to zero out. Once you have them, they are untouchables. The slants and the horizontals can be touched or crossed if you are near the origin. They weaken. All right, and then this last kind, so all of these are kinds you'll see tomorrow, and the command will be graph without a calculator. So I want to give you some strategies. So once you get the va and the ha or the sa, then you pick out a few points that are fairly easy to get and will help you get the rest of the graph. So then this kind, and again the command is graph, but this, when you see either the square root, y equals square root in the middle, or y equals x squared, or y equals x cubed, or y equals 1 over x, see I remembered, or y equals x, y equals a constant, y equals absolute value of x, and y equals the greatest integer function. Those are the big 8, and if you see those in the middle of the equation, then you can graph it like parent functions. So here we graph the parent, so you have to know all the graphs, the parents, and this tells me out front, tells me to flip it across x, this tells me to move it right, and this down 2. Alright. So just so you know the strategy on all the different types of graphing. Alright, that's all I want to say. Please study your comp books and your homeworks and just look at all the different kinds that we've covered and be ready to work well, focused, and confidently. So carry on.